Hello everyone. In this video, I am going to discuss about the data science assignment question paper solution. Let's begin. The first question is asking to explain the difference between supervised and unsupervised learning and provide examples of algorithm for each type of learning and discuss the scenarios where each would be appropriately used. So let's discuss the differences first. Supervised learning. It uses labeled data, whereas the unsupervised learning uses unlabeled data, only input features, no target labels. The goal of supervised learning is to learn a function and to predict output or classify new instances, whereas unsupervised learning main goal is to discover hidden patterns, groups, or structure in the data. The supervised learning includes typical tasks like classification or regression, whereas unsupervised learning include tasks like clustering, association rule mining, dimensionality reduction, etc. Supervised learning requires human-provided labels and often evaluation against ground truth, whereas unsupervised learning requires little human supervision or no human supervision. Supervised learning is used when correct outputs are known or the aim is accurate prediction on future data. Whereas unsupervised learning is used when the labels are unavailable or expensive and the aim is exploratory analysis or segmentation. The example algorithms and scenarios of supervised learning include the linear or logistic regression for predicting house prices or whether a loan will default, or decision trees, random forest, SVM, or neural networks, etc., for image classification or spam filtering. The unsupervised examples include like k-means or hierarchical clustering to segment customer by purchasing behavior, or a priori or association rule mining to find items frequently bought together in market basket analysis. Let's move to the next question. The second question asks to describe the concept of hypothesis space in machine learning and explain the algorithm of finders and find a hypothesis by the finders for the following instances in a training dataset. First of all, in machine learning, a hypothesis is a candidate description of the target concept. For example, which cars are positive. The hypothesis space is the set of all hypotheses the learner can represent, typically conjunction of attribute constants such as specific values or wildcard meaning any value. Next, the let's discuss the finders algorithm. The first step involved initializing the hypothesis H as the most specific one, and all attributes set to a null symbol, which such that no value is accepted. For each training sense, we ignore the negative examples, and for the positive example, we compare each attribute with H. If H has this symbol, then replace it with the example's attribute value, and if H has a different specific value, then replace it by a question mark to generalize. After all examples are processed, then H is the most specific hypothesis consistent with all positive examples. Then we can use this as finders algorithm on the given car dataset by first defining the attributes like origin, manufacturer, color, decade, type, class. Then we start with H node as 5 each of the symbol representing each of these attributes, ignoring the class attribute. And instance one will be the type of origin, manufacturer. Instance one is a Japan Honda Blue 1980 economy and positive. Positive so generalize from H0 to match the example, and H1 will be the Japan Honda Blue 1980 economy. Inside this we will demonstrate. Then instance 2 will be Japan Toyota Green 1970 sports negative and negative, so no change. H2 is equal to H1. Then instance 3 is Japan Toyota Blue 1990 economy and positive. Since we get a positive, then we compare with the H2 origin Japan versus Japan, keep Japan manufacturer Honda versus Toyota conflict. So we set two question mark. Color blue versus blue, we keep blue. Decade 1980 versus 1990, we get a conflict. So set two question mark. Then type economy versus economy. So we keep it economy. HT is equal to Japan question mark blue question mark economy. Now instance 4, which is USA Chrysler red 1980 economic negative. Since we get negative, so ignore H4 is equal to ST. Then instance 5. Instance 5 gives us Japan Honda white 1980 economy or positive. Then we compare it with H4 and origin is same, so we keep the same origin as Japan manufacturer Honda, so we keep already general. We need not to perform anything more. Color blue versus white conflict set to question mark. Indicate 1980 already general. type economy, so we keep economy, and final hypothesis will be keep as H final is equal to Japan question mark question mark question mark and economy, meaning all Japanese economy cars are positive regardless of manufacturer, color or decade. Let's move to question number third. Third question is asking to explain the purpose of training test and validation sets in machine learning. What is the cross validation and how does it differ from a simple train validation test set? Here, the training set is used to fit the model parameter. Validation set tunes the hyperparameter and selects the model, and test set gives an unbiased final performance estimate. Whereas the cross validation is used to repeatedly split the data into multiple train or validation folds, training on some folds and validating on the rest of the fold, then averaging the performance. While unlike this train validation test split, cross validation uses data more efficiently and gives a more stable estimate, especially on small data sets, while still keeping a separate untested test set for the final evaluation. Now, the question number four. The question number four is a give asking to given the confusion matrix, find the classification accuracy precision recall type 1 error, type 2 error, f1 error, f1 score, sensitivity, specificity. So first, true positive is equal to 6, false negative is 4, false positive is 2, and true negative is equal to 8. The formula of accuracy is true positive plus true negative divided by all of them, true positive plus false negative plus true negative, which is equal to 0.7. Precision formula is true positive divided by true positive plus false positive, that will give us 0.75 recalls. Or sensitivity formula is true positive divided by true positive plus false negative. So 0.6 will be the answer. Type 1 error is the FP rate is equal to false positive divided by the false positive plus true negative, that will give us zero point 0.2. Type 2 error of false negative rate is calculated by using the formula of false negative divided by false negative plus true positive, that will give us 0.4 as the answer. Specificity is calculated by using the formula true negative divided by true negative plus false positive. This will give 0.8 as a, and F1 score is calculated by 2 into precision into recall divided by precision plus recall, which will give us 0.666 as the answer. Precision and recall matter more than accuracy when class imbalance or different error costs exist. For example, in disease screening, where missing a sick patient is far worse than flagging some healthy people for extra tests. So it is better to understand the importance of precision recall as compared to accuracy. Let's move to the question number 5. It asks to discuss the importance of dimensionality reduction in machine learning and compare and contrast feature extraction and feature selection as two approaches to dimensionality reduction, and provide examples of techniques used for each approach. So dimensionality reduction removes the redundant feature, reducing the storage uh, uh, training time, overfitting, while improving the model interpretability and visualization. Feature selection keeps a subset of the original variables, filter, wrapper, embedded methods such as chi-square, RFE, and lasso. Whereas feature extraction transforms the feature into a new lower dimensional space, example PCA, LDA, or autoencoder, combining the original variables into informative components. Now, let's get a better understanding of these feature selection and feature extraction. Basic idea of feature selection is to choose a subset of the original feature and disregard the irrelevant or redundant one. Whereas the feature extraction basic idea is to transform or combine the original feature into a new smaller set of features. Data representation of the feature selection is original feature meanings are preserved and interpretable. While feature extraction, the new features may lose direct physical meaning but capture important structure. The typical methods of feature selection include filter or chi-square, correlation, wrapper, RFE, embedded, that is lasso. Whereas feature extraction typical methods include PCA, LDA, autoencoders, word embedding, CNNs, feature maps, etc. Feature selection is best suited for moderate dimensional data where interpretability and simplicity matters, whereas features extraction is best suited for very high dimensional complex data like images or text where patterns come from combination of features. So thank you very much for listening. The rest of the solution I will discuss in the next video.